Welcome to video number 3. In this video, we're going to take a look at some UI control objects. So this far, we've already created a button, or a UI button. A UI button allows us to present a button on screen for a user to tap, and when they do tap that button, we can execute some function. But UI button is not the only control object. By control object, I mean objects that allow the user to interact with your application. Another example of a control object is something called a UI slider. Anytime you use the built-in music app on an iOS device, at the bottom there's always the volume slider. Sliding it right increases the volume and sliding it left decreases the volume. In this video, we're going to take a broad look at control items. We're going to pay attention to how they're the middleman between our model and the user's capability to manipulate that model. And we're going to take a look at how we can use these various control objects to implement a model view controller pattern. So first, let's open up our browser and take a look at the UI button class reference on the Apple developer website. First, let's take a look at the classes that UI button descends from. So its immediate superclass is UI control. If we read the overview for a UI control item, we can see that UI control is the base class for control objects such as buttons and sliders that convey user intent to the application. You cannot use the UI control class directly to instantiate controls. It instead defines the common interface and behavioral structure for all its subclasses. So what this means is, the various control objects that you can use to allow the user to interact with your application are all implemented using the same concepts and principles. In a little while, we'll take a look at how event handling works with a few different control objects. If we scroll back up, we can see that UI control descends from UI view. At this point, you've probably figured out that in our first two applications, when we placed items inside of our view controller's view, we were essentially placing smaller views inside of a bigger view. Any item or graphic that can be displayed on an iPhone screen is either a UI view object or a UI view subclass. So what this means is, buttons, sliders, any UI control object is a view or a subclass of UI view with a very specific function. So for a UI button object, we have a small rectangular view with a graphic drawn inside that represents a button to the user. Okay, so now that we've discussed some of the principles of displaying a view for the user, both for presenting data and for allowing them to interact with your application, let's actually open Xcode and start coding. As always, we're going to create a new project. And as we've done in the past, we're going to choose a single view application template. I'm going to call my app Control Tests. And as always, I'm going to create it on the desktop. Let's begin by opening main.storyboard and dragging 3 different control objects onto our view. We'll drag a button, a slider, or a UI slider object, and a switch, which is a UI switch object. Now let's launch our application. As we expected, we can see our 3 control objects on the screen, but right now they're not of any use because interacting with them doesn't change anything in the app. So what we're going to do now is, we're going to add 3 labels to the screen. One here, and one here. The first one is going to display how many times we've tapped on this button. The second one is going to display the value of the slider. And finally, the third label is simply going to display whether the switch is on or off. So let's quit the application and go back to main.storyboard. Let's add our 3 labels. And let's change the text of each label just so we remember which is for what. And let's increase the size of each label, just to make sure we can fit the text that we put inside of it. Now let's center all three labels and center the text inside. Okay, so now let's run our application and see what we've got. Good. We have our three static labels and our three useless control objects. Let's quit the application again. So first, if you remember from the last video, if we're going to change the text displayed in each of these labels, we're going to need an IB outlet connected to each label so that we can programmatically change each's text. So let's do that first. Go to viewcontroller.h and add three IB outlets. The first one we'll call button label. Second one we'll call slider label. And the third we will call switch label. Now let's go back to main.storyboard and connect each outlet. In previous videos, we referenced the viewController object from this indicator down here. On the bottom left, however, of the storyboard window, you can see an expansion arrow. If we click on this, we can see the entire outline of our main storyboard file. So we have our viewController, the view that it manages, and all the subviews inside of the viewController. We can connect the outlets by either right-click dragging from the viewController item in the outline menu to the appropriate label on the screen, or we can right-click from the viewController in the outline menu and drag down to the appropriate label also in the outline menu. Let's repeat that the old-fashioned way just to make sure you're not confused. Okay, great. Now we have our three IB outlets and each one is connected to the appropriate label. Now we need the counterpart to IB outlet, an IB action, so that when these controls are interacted with by the user, they send a message to the viewController and tell it to update the text for all of our labels. To kick this off, we're going to connect UI button to its appropriate action first and take a look at how exactly a control object is connected to an IB action. So first, let's go to viewcontroller.h and add an IB action for our button. We'll call it increment button label. Save and go back to main.storyboard. Now, right-click and drag from the button to the viewController, and under Sent Events, connect the button to the increment button label action. So now, when this button is tapped, it's going to send a message to the viewController telling it to execute its increment button label method. What we failed to discuss thus far, though, is exactly when does the button message the viewController and tell it to execute the increment button label action. Though intuitively it seems simple for how a user can interact with the button, if you pause for a moment of analyzation, you discover that there are actually many different ways to interact with the button. For example, do we want the button to fire as soon as the user's finger makes contact on screen at the place the button is located? Do we want to wait until the user lifts their finger off the screen? What if the user taps the button but keeps their finger on the screen and then drags their finger around? To solve this problem and to decide on exactly when you want a control object to message its target and fire the action it's connected to, Apple has created something called UI control events. Let's go back to our browser and look up UI control again. Let's open the UI control class reference on the Apple developer website and scroll down a little bit. Under subclassing notes, there's a link titled UI control events. Let's click it and see where it brings us. Towards the bottom of this reference doc, we have a list of constants that represent all the different events that, upon happening, you want your control object to message its target and tell it to execute the action it's connected to. The ones we're concerned with are these top ones here. So, For example, if you tell a button to fire its action when the UI control event touchdown takes place, the button will message its target and fire its action as soon as the user's finger makes contact with the button on the screen. Or for instance, if we set it to fire when UI control event touch drag outside occurs, the button will message its target and fire its action when the user's finger makes contact with the button and then they drag their finger away from the button's location on the screen. Now let's go back to Xcode and take a look at which of these events the UI button has automatically been told to wait for before firing its action. Select UI button, and in the Utilities panel, choose the Connections Inspector. Here you can see under Sent Events all the UI control events we just saw on the UI control reference doc. If you remember, when we connected the button to the UI view controller and connected the increment button label action, all we did was right-click and drag from the button to the view controller and select increment button label. You can see automatically Xcode chose the touch up inside event. This means that the button won't fire until after the user has made contact with the button and then lifted their finger off of the screen from within where the button is located. So if the user were to tap on the button, drag their finger from outside where the button is, and then lift their finger, the button wouldn't fire its action. So only when the user taps the button and then lifts their finger back up does the button fire its action. But if you want, you can connect as many of these control events to all the actions you like. And you can even connect the same control event to multiple different actions. We're going to stick with touch up inside, since as a user, intuitively, that just seems the most obvious way to interact with a button. Also, it gives the user a chance to cancel the action if they decide once placing their finger on the button that they no longer want to commit to that action. They can simply drag outside of the button and then lift their finger off the screen, in which case the button will not fire its action. But what about for a slider? Do we really care when the user touches the slider and then releases their finger off of it? Is that really a useful interaction for something like a slider? The obvious answer to that is no, not really. So when do we care? What kind of event does warrant a response from a slider? Well, if we go back to the sent events list, all the way at the bottom we have something that says value changed. If we connect this event to the slider's action, it'll fire its action and message its target anytime its value is changed. So as soon as the user slides their finger left or right, changing the slider's value, it'll message its target and fire its action. And the same goes for UI switch. The only interaction we really care about for a switch is if its value is changed from on to off or from off to on. So first, let's implement our increment button label action. So go back to viewcontroller.m, and under the viewDidLoad method, we're going to implement the increment button label method. But first, we need an instance variable for our viewController class to store the current amount of times that the button was pressed. So go back to viewcontroller.h, and under the IB outlets, add an instance variable int num times button was pressed. Save and go back to viewcontroller.m, and in the viewDidLoad method, set the default value for num times button was pressed to 0, since when the application is launched, the button won't have been pressed yet. So now, the first thing to do when the increment button label method is called, or when the button is pressed, is to increment the value of num times button was pressed. So num times button was pressed plus plus. If you're unfamiliar with this syntax, this simply increments the value of the variable it's attached to by 1. So if num times button was pressed is 0 and this code gets executed, it'll be incremented to 1. If it's 1, it'll be incremented to 2, and so on and so on. Now that our model has been updated, in sticking with the MVC pattern, we need to update the view. So at this point, the button contacts the controller, the view controller. With this method, the controller updates the model, and then finally we have to update the view to reflect the updated model. Let's add a method called updateModel, and in here is where we'll update all 3 labels each time any control object is interacted with to make sure that all three labels are up to date and are displaying the correct value. At this point, since we only have a variable for storing the number of times the button was pressed, let's update the button labels text first. We can do that like this. Button label dot text equals. Now since we want to insert an int into an NSString object, which we then can hand over to the button label and tell it to display that string, we need to use formatting. Formatting in Objective-C with NSString objects is essentially the same as it is for C-string formatting. So we're going to call to a class method, an NSString class method, called string with format. This class method will take the string inside of the quotes and replace certain tokens with the succeeding values of the variables placed after the quotes in left to right order. So for this particular instance, we're going to place a token that represents an integer and then replace it with num times button was pressed. So first we're going to add the string button pressed :space. Now we want to insert the actual value of num times button was pressed. To do this, we insert the token %d. %d is the token for integer, and it will be replaced by whatever value comes after the comma after the quotes. So we can simply insert num times button was pressed. And now, again, this NSString class method will generate a string with this format, replacing all the tokens it finds with the values that come after the end of the quotes, and then it will return that string so that the button label's text property can take it and be updated, thus displaying the new text. So now, all we have to do to actually execute the updating of the button label is to make a call to the update model method as soon as num times button was pressed is incremented. Since the update model method is implemented within this viewController class, we can execute it by calling self update model. Since it's likely that you haven't yet grasped exactly how method calls work in Objective-C, a method call in Objective-C starts with an open square bracket, followed by the object that you're going to be sending the message to, followed by the method you want to send it, or the method you want to tell it to execute. In this case, this method doesn't have any arguments, so we can simply say self update model. You'll very quickly catch on for the syntax for executing a method in Objective-C when we start calling to methods that actually have parameters. So now let's run our application and see what it does. So if we press the button here, you can see that the text in the button label is adjusted accordingly. Since the button will only fire when UI control event touch-up inside occurs, you can see that if we press down on the button but we don't release, it doesn't fire its action. And if we press down on the button and we drag outside of where the button's located and release, it still doesn't fire its action. So only when you click the button and let go inside where the button is located, or inside its bounds, which is about that, will it fire its action. Now let's do the same thing for the slider and the switch. So first, add an IB action for the slider. Go back to main.storyboard and connect the slider to its IB action by right-clicking and dragging to viewController. Select Update Slider Label, and you can see that by default, Xcode assumes that you want this method to be fired when the slider's value is changed. And as we discussed, that's the only real event that upon occurring do we care that the users interacted with a slider. Now let's go back to viewcontroller.m and implement the Update Slider Label method. Now, a slider does store internally its current value, but for consistency's sake and for the fact that we're trying to follow the MVC pattern, which asserts that a view is based on its model and not the other way around, we're going to add an instance variable for storing this slider's value. In this case, we need to add a float. By default, a slider's minimum value is 0 and its maximum value is 1, and anything in between will be a decimal. You can change the minimum and maximum values of a slider let's just leave the minimum at 0 and the maximum at 1. Let's go back to viewcontroller.m, set the default value for slider value to 0. But now, we need a way to reference the UI slider so we can grab its value. There's two ways we can do this. The first way is we can make an IB outlet and connect it to the slider, and then once the slider fires its action and this method is executed, we use the IB outlet to reference back to the slider and grab its value. The second way we can do this is we can pass the slider itself in as an argument for the update slider label method and then just reference that argument. For now, we're going to stick with option 1 since that's easier to understand at this point in the series. So, go back to viewcontroller.h and make a new IB outlet of type UI slider and simply call it slider. Now go back to main storyboard and right click and drag from view controller to the slider and connect the slider outlet. Now we can go back to viewcontroller.m and update the slider value instance variable to the value of the slider. We can do that by accessing the slider's value property. So any UI slider object has a value property and it stores the current value that the slider is displaying. Now we need to add another line of code to our update model method that updates the label for the slider label's value. So we can do that the same way that we changed the button label's text. Slider label text equals NSString with format slider value. But this time we need %f because the token for a float is %f. And finally, let's add a call to the update model method and run our application. So, pressing the button, you can see that pressing the button also updated the slider value label, and that's because increment button label method makes a call to update model, and update model updates both the button label's text and the slider label's text. If we slide the slider left and right, you can see the value of the slider being imposed on the slider value label. But if you noticed, when we first launched the application, when we pressed button, the slider value said 0, but the slider is set at 0.5. The correct value is 0. Since we're following the MVC pattern, again, a view is supposed to reflect the model that it's representing. So the model by default has slider value set to 0. So we need to set the actual UI slider view object to represent that default value. The way we can do this is, as soon as the view loads, we can set the slider value to the slider value instance variable. Now let's run the application again. Click our button, and you can see that the values match, 0 and 0. Finally, let's do the same thing for our switch. Add an update switch label method. Go back to main.storyboard, connect the switch to the appropriate method. Save, go back to viewcontroller.m and implement this last method. And now, again, to keep with our MVC pattern implementation, we need an instance variable to store the value of the switch, and we also need, same with the slider, an IB outlet to connect to the switch so that when its value is changed and it does fire its action, we can grab its new value, whether its new value is on or its new value is off. So, go back to viewcontroller.h. We'll add the instance variable for the switch's value first. A UI switch has a property called on, which stores a Boolean value, yes or no, which determines if the switch is on or if it's off. If the switch is on, its on value will be set to yes, and it'll be displayed as on. And if the on value is set to no, the switch will be displayed as off. So we need to make a Boolean value as an instance variable to save the on or off state of the switch. We'll call this switch value. And also we need an IB outlet to connect to the switch to grab its new value, and we'll call this our switch. We can't call it simply switch because switch is an Objective-C keyword used for switch statements. So now let's go back to main.storyboard, connect the our switch outlet to our UI switch object, save, and now we can go back to the viewControl.m. First, set the default value of the switch value variable to no. Then set the switch's on state to reflect this initial off state. Our switch.on equals switch value. And now we can implement the update switch label method. So first, switch value equals our switch.on. Now, if the switch has been set to off, we want our label to say switch value off, and if it's been set to on, we want our switch value label to say switch value on. We can do this with an if statement. If switch value equals yes, switch label text equals switch value on, else switch label text equals switch value off. And finally, we make a call to our update model method. Now let's run the app. So if we change the value of the switch, you can see the switch label's value is adjusted accordingly, as is also the case with our other control objects. The final step is to program the app to display the default values for our three labels before there's any interaction with our control objects. So I'll quit the app, and to do this, all we have to do is make a call to self-update-model at the end of the viewDidLoad method, and we can run our app again. Perfect. So you can see that using view controllers and the various control objects that come bundled with UIKit, it's very, very easy to maintain an MVC pattern in your application. And personally, I think that that's the best route to take, because in that implementation, everything is always organized, and there's always an understood direction of flow between user interaction, the data model that stores the data in your app, the view that displays the data, and the job of the controller to mediate the situation in between. The final thing I'd like to show you in this video is that you can programmatically give a control object the action it's supposed to fire when the user interacts with it. So let's go to viewControl.h and add an IB outlet for our button. Go back to main.storyboard and connect this new outlet. Now select the button, and in the Connections Inspector, cancel the link between the TouchUp inside event and the call to the increment button label action that belongs to the viewController class. You can do this by clicking on this tiny X at the top left of the box that represents the viewController. So now, if we run the application, you can see that pressing the button doesn't do anything. Go to viewController.m, and towards the top of the viewDidLoad method, add this line of code. Open square bracket button, add target, and you can see that Xcode suggests the method you're probably trying to call. This method, add target action for control events, can be sent to any object that descends from UI control. You can send this message to a UI control object to tell it what particular object its target is, or which object to message when it wants to fire its action, what action that target is supposed to execute, and for which control events should this control object fire its action. So first, for the target, we're going to put self. Since we're adding this code from within the viewController class, we want the button to send a message to this object. And again, we can reference that with the self keyword. Next, the action. Well, if you remember, the action that the button was linked to before was the increment button label method. Well, we can denote this using the @selector keyword, and then by placing the method signature inside of these parentheses. Since this method doesn't have any parameters, the method signature is simply increment button label. And finally, after for control events, we can list the control events upon whose occurrence we want this button to fire its action. So, to stick with what we had before, let's pass in the constant UI control event touch up inside. Add the final semicolon, save, and run your application again. You can see tapping the button now results in exactly the same behavior we had before. The point of adding this line was to demonstrate that anything you can do with the Xcode GUI for creating interfaces can also be done purely programmatically. Anyhow, this concludes video number 3. Head on over to video number 4 for an introduction of table views, or in the iOS SDK, a UI table view object.